And we are live, I think. At least that's what I hope. Nope. YouTube channel. Yeah. And we are live. Yeah, we are live. Okay. So we were working on the terrain, or watching YouTube videos on the That's great. The chat for anyone listening. No one. No worries. Obviously nothing happened from the last stream. We were just simply learning about the terrain. And I think we can start building at least the mesh. So ideas from the videos. So some things about he uses left-handed coordinates, we use right-handed coordinates. He uses clockwise winding order, we use counterclockwise winding order. 2D array of floats. Okay. First thing first, we need to build our terrain. Is just a grid of floats. We need to understand our terrain will be basically like a square, and we will be subdividing our square like this. Basically we have our square going from 0 0 to 1 1. Okay, so our unit square, we specify a subdivision factor. So many times we want to basically split it. Okay, subdivision factor of 0 means okay, no splits. Subdivision factor of 1, it means 1 split. So subdivision like a subdivision, let's call it like that. Subdivision factor of 0, we don't split. So we have something like this. Our terrain it's just a quad. Subdivision factor of 1, well, we do indeed split. We do 1 splitting basically. So do 1 subdivision. So we split 1, do 1 split on the horizontal and 1 vertical split. The subdivision factor of 2, well, it's basically we have our quad and we split 2 times. So we do split, 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 split. Okay. And we have here we have 4 vertices. Here we have 3, 6, 9 vertices. 4, 8, 12, 16 vertices. Okay, etc. And this is basically our our mesh, okay, our terrain mesh. Not really, this is just the grid. Then we have to like have the quads. So sorry, we have the quads, we need to basically have the triangles, something like that. That's the mesh, and then that's our terrain mesh basically. But our terrain per se, it's just the points, these points right here. Okay, for each point we just store the height for each point. We just store the height, and I think does it work? I'm just curious actually. So if I subdivide it like this, GZ, yeah, GZ, GZ, yeah, GZ, GZ, whatever. Yeah, it works. I can give them any sort of any sort of height, it doesn't matter. Okay, fantastic. So that's the, we just store the height as a float. That's it, that's our terrain basically. And then from the terrain, from the sequence of points, we just like can build the mesh. And once we have the mesh, we can render it. Nothing really fancy. Nothing really fancy actually. So let's do some coding for now, at least. Let's do some coding. To get things started. So we need our terrain thingy. So let's make a new file. And create, let's say a class for now. Const copy constructor, move constructor, and assignment operators. No destructor, or sorry, the default destructor, because we don't care. And here we have the subdivision factor. Subdivision factor, it's an integer, so int sub and subdivision factor, or just m subdivision. And then we have a include math position, vector 3, we don't really need a rotation, a scale, yes, scaling, position, scale, okay, and let's ignore them for now. No, we need it. Do we really care about it? Float. Float, just a size. The terrain, obviously. Int subdivision float size. Here we give the m subdivision, the m size, the size. What? Am I completely insane? Oh yes, obviously. Most importantly, we have a std unique pointer float, that's an array, size or side, it's a square. I like it better. Float, unique pointer, okay. M points, data, the terrain data. What do we do? Well, the side subdivision, the side, from the subdivision we can compute the we can compute static int compute number of points, number of, so let's call it date points, not really. Yeah, but data, it's too generic. I mean, yes, like points, compute number, get points count. get what? Well, here it's 4. This is 9. What's the... Oh yeah, this is 2 to the power of 2. This is 3 to the power of 2. This is 4 to the power of 2. Okay. If yeah, so this is the 2 plus the subdivision factor squared. So this is 2 plus the subdivision factor squared is 4. This is 2 plus the subdivision factor, which is 3 squared. 4. If I did this, we have 16, 17, 18, 19, 20, 21, 22, 23, 25, which is 5 squared. Fantastic. So this is very simple. Constext return 2 plus the subdivision times 2 plus the subdivision. Here then the endpoints is std make unique float with the get points count and subdivision. Fantastic. Here we need to... No, that's it basically. Public set void set point float height, and this is just endpoints set point int x int y, the height, the points height. How? Well, our points are stored like that, so this means that our points are stored. Let's use this as an example. Let's do some drawing is always helpful. Drawing is always helpful. So let's check. So we have 1, 2, 3, 4, 5, 6, 7, 8, 9. Okay, so this is the point count, and this is the layout in memory. So this has index 0, 1, 2, 3, 4, 5, 6, 7, 8. So we know the count, we don't know points count, but we also know the points side. We also know the points side. What's that? It's just the 2 plus the subdivision factor. So this is 2, 3, 4, yeah. If I were to say 3, this is 1, 2, 3, so it's 1, 2, 3, 4, 5. Okay, so the point side is just 2 plus the subdivision factor. So 0, 1, 2, 3, 4, 5, 6, 7, 8, but this has coordinates. If this were a matrix, this is 0, 0, 0, 1, so row, column, 0, 0, 0, 1, 0, 2. This is 1, 0, 1, 1, 1, 2, so row index 1, column index 0, column index 1, column index 2, and this is 2, 0, 2, 1, and 2, 2. So the idea is that if we want to get like this right here, from, if you take the index I, if I want to get the x, that is, if I want to get the row, I have to know how many times the number of columns fits into my index, basically, and that's a division. So how many times the number of columns fits into my index. So I have the I divided by the points side. The column, once I know the row, I want to know the offset from the start. So basically, not to find the row, I have to find like how many times the point side fits into my index. To find the column, I have to find the remainder. Okay, so basically is this. Okay, from an index. If I want to get from an index, okay, if I want to get the index, well, if I want to get the index, for example, I want to get the index of 1, 2, well, it's the first row, so it's row index 1, so, and I know that this means that I have my index, if I am at row index k, I know that I went through like k minus 1, k plus 1 rows. Okay, so basically each row I know that has calls elements, so I just take row times yeah, the row, the current row times the point side. Okay, so basically if I want something on row 1, I take 1 times point side, which is 3 in our case. So obviously it's 0, 1, 2, 3. Then I say, okay, this gets me to the starting point, starting index of, say, the row, but I have to actually find the correct element. How? Summing up the remainder. Okay, summing up the remainder, which means the column I desire. Okay. For example, I want column index 2. Well, I'm here, so it's 0, 1, 2, 3. Okay. Now I add to it 2, so it's 4, 5, and I find 5. If I want 1, it's 0 times 3, which is 0, plus 1. Okay. If I want the index of 7, so the index of matrix second row index 2, column index 1, I do 2 times 3, which is 6, plus 1, which is 2 times plus 1, which is 7. 0, 1, 2, 3, 4, 5, 6, 7. Okay, so here the points is, let's just const static int get index from get index, so int x, int y, x. Okay, I don't really want oh yes, I actually do. So we need, if I do this in my like idea, if I use x as the row and y as the column, I get something like this. Okay, but first and foremost, I don't want xy, because I want to match, I want these to match the positions in space, in my I'm not saying word space, but you know, in my modular space. So the idea is that I have the x, I have the y, and I have the z. The y is the height, basically, component. So I want the x, and I want the z. Okay, meaning that this is xz. Okay, so actually what I want is something like this, the x and the z. So this 0, 0 right here will be 0, 0 at the origin. The 0, 1 will be 0. Sorry. If I do something like this, what? So in this case, this is the z and this is the x, because this is x0, x1, x2. Okay, and this is the z, z0, z1, z2, and we have our x, y, and z So the x is right there. Okay, the x is right there. X, y, z. Okay, we are looking up basically, like we are looking down on our terrain. Direction is minus z basically. And yes, everything actually makes sense. So it's zx. Yeah. Because it's basically, okay, x and z. So 0, 0, 0, 1, 0, 2. Okay. Fantastic. So this is the x. So here, x and z. Here, x and z. The x is basically the column, and the z is basically the row. Z is row 0, row 1, row 2. The x is the column 0, column 1, column 2. So basically the row is z and the column is x. So this becomes, if I want to find the index, this is z times point side, so const x static int const x static int get apart from the fact that why the const x get points side int subdivision return 2 plus subdivision. Okay. So the points count is actually the int points side get point side and then do something like this. Fantastic. Get the index, well, we get the point side passing the subdivision. So we need the subdivision. We need the subdivision, and then so the z times point side plus x. Static int std tuple int get and at this point I think I'll just return the row is the z, the column is the x, but like imagine it like this, imagine it like this. This is the z and this is the x. So first the z and then the x basically. well, first we pass the x and then the z, and so first we pass the x, okay, so I tac get points side an int I. Oh my, hello. If there is someone watching, please wants to have like some sort of conversation, I'm open, don't worry. So subdivision int I modulus gets point side, and we pass the subdivision, and then for the column, so first the x and then the z, it's I divided by the point side. Yeah. I think at this point I'll simply do this and save. So this side, let's call it scale. Because it's this. Scale. No. Scale. Oh my. And here we'll just get point side and some division. Const. Get points. Obviously no subdivision. No subdivision. Get the index. Const. Once I know the subdivision, automatically know the side. So just 2 plus the subdivision. Once I know the side, I know the count. Which is m side times m side. So get side, get count, get side, get points, points side, get points, count, set point, void set point with an index, endpoints I height, set point, okay. And count, so here we can pass the and count. So we create that array passing subdivision and a scale. We get the points side, we get the points count, set the point in two ways, get the index, get the coordinates, and subdivision and side and count and scale and points. Yeah. Alright. Well. Get point. Sorry, float. Oh yeah, because I can access it in different ways. I want them to be consistent. Yeah. SCH namespace Lucy. No. Please stop it. Nothing really fancy here. So we implemented the terrain abstraction. Now let's put it here, put it in here. Now we'll run and we pass the subdivision, let's say 2, and the scale let's say 8. If I run it, nothing should happen, including nothing should break. Terrain, subdivision 2, side 4, count 16, scale 8, and the points is just there. Everything zeroed out as should be. Let's commit, implement terrain abstraction, and now we should build the terrain mesh. So to do mesh. How? If I go in the CPU mesh H, this is import. To do midpoint. Why should the CPU mesh know about the terrain? Shouldn't the terrain be the one? But these basically are mesh I'm making auto mesh here, specify the vertex count, the index count, so we just specify vertex count, index count, I could probably just use the constructor at this point. Like, why not? Oh boy. Vertex count, index count, mesh, index count, and then return the mesh, and do the location for us. So mesh, vertex buffers I, the 3D make unit float model, vertex count, mesh, get floats per vertex. And here model mesh indices, make unit, mesh index count, return mesh. Fantastic. So here is the make empty. So here we call the make empty passing the num vertices, the num faces times 3. This we throw it away, this we throw it away, and then so it is here. Right here we have our initialization thingy. Let's the constructor private. While the other things are so we cannot instantiate a CPU mesh per se. We can only do it right here. No. Yeah. To do. Think about it. Think about it. Yeah. Because okay. Run the program. Oh my god. Ah, good lord. Something like can a private member the constructor basically. Yeah. I tried but I failed. Yeah. So everything works fine. My bad. Okay, here we go. So we should like at this point, why use the unique pointer? Why use the unique pointer? Come on, we can do better than that. So why use we can do better than that, like, because this basically our mesh, our CPU mesh, it's just a structure. It's basically a fat pointer. Not quite, it's a collection of fat point. It's a collection of pointers plus some metadata. There is no need to allocate all of these on the heap. why allocate it on the heap? We can like just be clever with the no copy, just move, because we don't want to copy. Copy is expensive. We may want to move, yes. Getting like okay, so we could do better, but not now. Let's do the terrain thingy, then we'll worry about it. Okay, so everything works now at least. So we build the terrain mesh to do it. We do it in the terrain and say should we put it in the terrain or in the CPU mesh? Not really in the CPU mesh. Should we put it in the terrain? Well, should we just, okay, so don't worry about it for now. Let's just do this std. So, sorry, auto, terrain mesh, CPU mesh, make empty. Oh, A Pro. So we want the index count, so we want the vertex count and the index count. How many vertices? Easy. It's the count, it's the points count. So it's terrain dot get points count. How many indices? How many indices do we need? Well, 1, 2, 3. So 1, 2, 3. 1, 2, 3. So we need the number of quads. So this is 1 quad. This is 2 quads. 3 quads. 1, 2, 3. So we need the number of quads and multiply it by 6. 3, 4, 5, 6, basic. How do we get the number of quads? The number of quads is just the terrain get points side minus 1 times 6. Then, because with this side is computed as 2 plus the M subdivision. Well, with a subdivision of 0, the side is not 2 though. Oh, is the number... okay. It's points per side. So it's not the side. It's the points per side. It's the points per side, and this is the points count. The points per side points per side is this. The points per side, points count, it's the points count. Okay, fantastic. So this is get points per side minus 1. This is the number of quads. How do we build the terrain mesh then? Oh Lord. I'm getting bombarded by messages. Good question. Well, the idea would be for every one idea could be put all the points, so like a row major order, how they are stored basically in memory, and then do the indices or do it per quad. So if you do it per quad, yeah, we can do it per quad actually. I think this is a better idea. So, oh, but if I do it per quad, Okay. So figure the terrain mesh. So first and foremost, it would be to vertex and we have positions, normals and UVs. So for int I less than the terrain dot get, let's count I plus plus terrain mesh vertex buffers CPU mesh vertex buffer index positions 0 1 2. It's just like that. So the x would be auto x z terrain dot get terrain getters, let's put them before the setters. So get chords fly past the eye, and it's actually the x first and the z then. Okay. Okay. So I get the coordinates, that's the x, that's the z, auto, the y will be terrain dot get point, let's put it I, y, fantastic. So X, Y, and Z. Okay. These are the vertex buffers. So these are the positions. Then we have the normals. And the normals, I don't know, 0, 1, 0. And the UVs. The UVs. This would be UV 00. This would be UV 11. So this is wrong, like this is wrong, this X, this Z, it's not the it's not the correct way. It's not the correct way. Okay, yeah. This is my tiredness and my being distracted because people message me. Yeah, this is not right. Because like the X and Z, the X and Z that we see here are just columns and rows, nothing else. Nothing else. Okay, not the real X, not the X and Z that we need to use to build the mesh. I forgot this little detail right here. Okay, I'll fix it tomorrow, okay, because I'm getting tired and I know when to stop. It's very long. So yeah, start building terrain mesh. This to do not right. Okay, so start building terrain mesh. It's the comment message. And thank you for those who tuned in. Fantastic. 3 viewers. This is epic. I never had 3 viewers on stream. Let's like party a bit. Can't send it. But whatever. Let's party. Fantastic. Great milestone. And tomorrow I'll work on it. Tomorrow afternoon here in Italy, so I think tomorrow morning in the US basically. So yeah, Have a good night or good day, good afternoon, good evening. I sound like Heartbeast, yeah. So let's like let's